We're going to continue on with our look at polynomials, and we're going to talk about how we can add and subtract them. Our focus tonight is going to be on adding, and tomorrow we'll kind of ease ourselves into that subtraction piece. So, to do this, we need to make sure that we really understand our idea of like terms. And I know that this is not a new concept. We've talked about like terms several times before, but it's good to review before we start mixing them all together. Remember that like terms have to have the exact same variables to the exact same powers. That is super important. Just because they're both x's doesn't make them like terms. If one is an x to the third and one is an x to the fourth, they're not like terms. So some examples of things that are like terms would be 2x to the third and negative 6x to the third. Even though the coefficients don't match, remember that's just telling us how many x to the thirds we have. So if I were to combine those together, I would say 2 and negative 6 makes negative 4, so I have negative 4x to the third. They would not be like terms if it was 2x to the third and negative 6x to the fifth. Those aren't like terms because those don't match. The exponents are not the same. Same variable, but they're not the same powers. Okay. Another example of like terms would be like x squared y and 3x squared y. They both have x's and y's, and on both of them, the x is to the second power and the y is to the first. Sometimes people get confused. They see something like x squared y and xy squared. They see x's and y's in a squared, so they think that those match. But pay careful attention. On the first one, the squared is on the x, and on the second one, the squared is on the y. Those don't match, so that's not like terms. The other thing you want to watch for is if I have something like 1/2 x to the third and 2/3 x to the third. Again, they're both x to the thirds. But what people will do sometimes is they have something like 1/2 x to the third and 1/4 y to the third. They say, oh, well, those are both to the third power. But again, why are these not like terms? One's an x, one's a y. They don't represent the same things. So you have to make sure that they are exactly the same. Close is not going to cut it. They have to match exactly. Okay? So when we add polynomials, the basic idea is we are just going to combine all the like terms. And remember, anywhere you see a subtraction just means that the term is negative. So there's two different methods we can use here. I'm going to show you the first one using the horizontal method. The best way with the horizontal method is to use some sort of coding system to make sure that you match up all the terms that are the same. So I'm going to use different colors. You can use different shapes. You can circle them, box them, underline them, however you want to tell the difference. So looking at this first one, I have an x squared here and an x squared here. So 3x plus, remember this is a 1x squared, that makes 4x squared. And then I have an x to the first that's positive and a 4x to the first that's positive. So again, this is a 1x. So 1x plus 4x makes 5x. And lastly, I have a negative 6 and a positive 10. And so when I put those together, again, you got to watch real careful with your positives and negatives. I get plus 4 at the end. And that's going to be our solution. We've combined all of our like terms. I'm going to do a quick scan. I have an x squared, an x, and a constant, so none of those match. I can't combine it any further. One thing that I want to point out to you is notice that when I coded these and when I selected things, I included the sign with each one of my terms. That's really important because, again, even though that's a minus 6 at the end of that expression, it's a minus because that 6 is negative. And so if you just count the sign, then you can include those together. All right, the second example that I want to show you, I'm going to use a different method, which is to use a more vertical method instead of a horizontal method like that. You don't have to know how to do both of these. Whichever one you like better should be the one that you do. Now, the first thing that I'm going to do is I'm going to write out my first one, and if any of the powers are missing, I'm going to leave a space. For example, if we look at this, I have x to the third, x to the second, x to the first. I don't have that constant term in there, so I know I'm going to need a space there. If I look at this one, even though it's out of order, I have an x to the third, an x to the second, and then I go straight to a number. So you see I'm missing that x to the first spot. So we're going to have to leave a space there. So I'm going to rewrite the first one with any spaces that I need. And there's basically a space after that x, but we may or may not need it. Now, with this one, the second polynomial, I'm going to line it up with the terms that match it. So the 2x squared lines up with the 5x squared, and it's positive, so I'm going to go ahead and put a plus. The x cubed, and that's a 1x cubed, is going to line up with that one. There is no x term, so I'm going to leave a blank, but then there should have been a constant term out here at the end, so that's where I'm going to line it up for this one. Now, we just add straight down. So 2x to the third plus 1x to the third is 3x to the third. Negative 5x squared plus positive 2x squared is negative 3x squared. There's nothing to add to this one, so he's just going to come straight down. And there's nothing to add to the negative 1, so it's just going to come straight down as well. And so here's our simplified polynomial. I personally like the vertical method better because it collects all your like terms in nice, neat columns. So then you've decided all that right off the bat. When you do the horizontal method like we just looked at, sometimes you have more than just 3 or 4 terms, and it can get kind of messy trying to figure out which ones match, what code have I not used before, what color have I not used before, and so that can get kind of tricky. When you have a whole bunch of stuff, I like to use this vertical method. Now, what I want you to do here is to go ahead, ignore that little message in the corner, and in your notes, I want you to complete this example on your own. I want you to copy down the 2 examples that we already did, and then complete this one on your own. So this is going to be your ticket into the activity tomorrow. All right? See you then.